Welcome to my channel, dear students and all the viewer. See, this is the subject of about the eigenvalues and eigenvector corresponding to the some matrix is given here, and the value of matrix are saying row wise. The first row is there occur 1 minus 1 0, and the second row is there 0 to 0, and it is given that the third row is there 0 minus 1 0 minus 1 and 1. Okay, and this subject is related to the class of b.sc and b.tech and also the math honors. So let us assume a matrix A, which is given that is 1 minus 1 and 0, and 0 2 and 0 0 minus 1 and 1. Okay, now first find the value of A minus lambda I, and mod of A minus lambda I equal to 0 is called the characteristic equation. So first find A minus lambda I. So this is equal to A means here 1 minus 1 0 0 2 0 0 minus 1 1, and this is lambda time of identity matrix of order 3 is 1 0 0 0 1 0 0 0 1. Okay, so this is here 1 minus lambda minus 1, this is 0 minus 1 0 minus 0, this is 0 minus 0, this is 2 minus lambda, this is 0 multiple of lambda, this is 0 actually, and 0 minus 0. Okay, and the second element of the third row is here minus 1, actually this is minus minus 1. Okay, and 1 minus lambda, 1 minus lambda. Okay, so now the determinant of A minus 2I, and that is equal to 0. This is called the characteristic equation. Now this is here 1 minus lambda I minus 1 0 0 2 minus lambda 0 0 minus 1 and 1 minus lambda. Take common, this is equal to 0. Take on 1 minus lambda from the first column and 1 minus lambda from the third column. So this is whole square. So this is 1 0 0 minus 1 2 minus lambda and minus 1 0 0 and 1. I can take common the 2 minus lambda from the second row. So it would be here 1 minus lambda and whole square. This is 2 minus lambda from the take on 2 minus lambda from the second row. So this is, we have left the determinant here is row as I am saying that 1 minus 1 0 0 1 0 0 minus 1 1 and equal to 0. If we expand, the value of this is actually 1. Say if we take 1, then corresponding row column are cancel out. So 1 0 minus 1 1. So if we expand, this is 1 actually. Okay, so we have the value of lambda. The equation is that 2 minus lambda equal to 0. Therefore the lambda is here 1 comma 1 comma 2. Okay, the characteristic equation of the matrix A, the characteristic equation of the matrix A is 0. So therefore 1 minus lambda whole square 2 minus lambda equal to 0. Therefore, lambda equal to 1, 1, 2. Okay. Hence the eigenvalues hence the eigenvalues hence the values are 1, 1, 2. Okay. The eigenvector of the matrix A corresponding to the eigenvalues corresponding to the eigenvalue lambda is given by the matrix given by the non-zero solution given by the non-zero solution of the equation, that is a minus lambda I into x equal to 0. Okay. For lambda equal to 1, then we have for lambda equal to 1, then this is a minus lambda I. This is here a minus lambda I. So this is here a minus lambda I. So 1 minus, this is lambda equal to 1. If we put here 1 minus lambda, this is be 0, minus 1, 0. This is 1, 0. This is 0, minus 1 and 0. And column matrices are x1, x2 and x3 and 0. Implies that this is 0, minus 1, 0, 0, 0, 0, 0, 0, 0. And the column here is x1, x2 and x3. And this is the 0 here. See, second row and third row is 0. If we add with first row with second, then we got here 0, 0, 0. And third row minus first row, we got 0, 0, 0. So we see that the order of matrix here is 1. Order of matrix is 1. So now we can see the rank of the characteristic equation is 1. Therefore, this is x2 is equal to 0. Thus, the rank of thus the rank of the characteristic matrix is 1, and hence the equation have and hence the equation have, this is the order of matrix here is 3 and the rank is 1. So we got here 2 linearly independent solution. So that is x2 equal to 0. So two independent solution are, this is x1, this is here in the column of, this is x1, x2, x3. So see, x2 is here 0, x2 here is 0. So the vector is here multiple, some scalar multiple of here is the other matrix. So I need to take as a x3 is 0. Then we got here x1. So this is the x1 multiple of that. Okay. And now this is x2. Same as x2 here is 0. So if we take x1 as a 0, then the multiple of x3. So this is the multiple of x3 here. Okay. So x1 and x3 non-zero. x1 and x3 are non-zero for the different type of finding defined vector of that. Okay. So every non-zero multiple of this column vector is an eigenvector of A corresponding eigenvalues lambda is equal to 1. For lambda 2, when lambda 2, then the value of lambda is 2. So not I'm saying wrongly said that lambda 2, this is the value of lambda is 2 here. So, and this is the characterization. So put here 1 minus 2. We got here minus 1. And again this is minus 1. This is 0. 0, 2 minus 1. This is actually 1 and this is 0. Okay, I am saying this is 2. Sorry, this is actually 2. So 1 minus 2, this is minus 1. 2 minus 2 is 0. So this is 0, minus 1, and this is minus 1. And here is a clear view is that if we take any order 2 matrix, we got the value of the order 2 matrix determinant is non-zero. So the rank of this matrix is here 2. So the rank of this matrix, therefore the rank of this matrix is 2. Okay, hence the number of independent solution. Hence the number of independent independent solutions solution of the equation will be this is the order of matrix here is 3 and the rank is 2, so we got 1. So we get one solution, independent solution. Okay. So that is here. If we multiply first row with the this column, we got here minus x1, minus x2 0, and minus x2 and minus x3 equal to 0. From this one, so we got here x2 is equal to minus x1, and from the second x3 is equal to minus x2, and minus of minus x1, the value of x2 is here minus x1, so we got here x1. So therefore the matrix X is equal to, this is x1, x2 and x3, this is actually a recurrent vector, okay, and that will be here x1. So x1 is unchanged, x2 is minus x1, x3, this is x1, see, and this is the scalar multiple of x1, which is non-zero, 1, minus 1 and 1, okay. Therefore x3 is equal to the x1 multiple of 1, minus 1 and 1 plus 1 actually. So is an eigenvector of A corresponding to the eigenvalue lambda is equal to 2, okay. Okay, here is therefore this is your recurrent solution. Here is the question, the eigenvalues. So here is the eigenvalues is here 1, 1, 2, and the eigenvector is here 1, 0, 0, 0, 0, 1, and the third eigenvector is here 1, minus 1 and 1. Okay, thank you for watching my video.